All right, I'm back. I'm sure you were missing the math. Okay, so now the focus is going to be on actually applying the dilations, which really, as compared to the theory, applying it is more important and it's also more straightforward, maybe even easier, you might want to say. So here's what I'm going to do. I made this little table and I used 2 points. Point P, which is 6, 8. This is a pre-image. Same with Q. Negative 2, 4, also a pre-image. And what we're going to do is we're going to apply each one of these dilations to the points. So what I'm going to do is I'm going to kind of bounce back and forth, but I'm only going to do one for each of the dilations. This way, if you choose to print out, and I would urge you to do this, print out the notes, you can fill in the missing pieces and know if know if you're feeling good about it or not. All right, so here goes. If I take the original point, right, pre-image, 6 positive 8 for point P, and I would apply the dilation centered at O, the origin, with scale factor 2. All you're going to do is take this 2, all right, and you're going to multiply it by those 2 coordinates. So your point P prime would be 6 times 2, 12, comma 8 times 2, 16. All right, that's it. All right, so if it was negative 2, 4, I'm going to break what I said before. I'm going to do both of them for just the first one. My Q prime, my image, would be negative 2 times 2, negative 4, positive 4 times 2, positive 8. So now if I was to go to, say, the next one, all right, now it's the scale factor 3. Oh, okay, so if I scale factor 3, that means multiply by 3, multiply by 3. So P prime would be 6 times 3, 18. 8 times 3, 24. Now, if the center of dilation was the origin here, think about it. 6, 8 is not that far, but 18, 24 is way further. In fact, it's 3 times further. All right? So what if I was centered at the origin of scale factor a half? Oh, now we're in that area of your K value where you're going to be shrinking closer. So maybe Q prime here would be same concept, just multiply by a half. What's half of negative 2? Negative 1. What's half of 4? 2. So this point is closer to the origin than this point. All right, same concept. Oh, wait, same concept, but now we got a negative scale factor. I didn't talk about that, but I will right here. All right, a negative scale factor doesn't change anything from an application standpoint. So if I'm applying, scale factor negative 2 to 6, 8, I'm just going to take that point and multiply both by negative 2. 6 times negative 2 is negative 12. 8 times negative 2 is negative 16. Now, these points here were twice as far away from the origin as 6, 8. 12, 16 is twice as far away from the origin as 6, 8. Negative 12, negative 16 is also twice as far away from the origin, but the negative changes both of the signs. All right, so if you were over here, I'll do the negative, the centered at the origin of scale factor negative 1 to Q prime. So negative 2 times negative 1 is positive 2. 4 times negative 1 is negative 4. All right, these are actually the same distance, but we've changed the signs of both. So when you have a negative scale factor, you're going to reflect across the origin. And really what that does is you're going to flip-flop in your coordinate plane. So if you were in quadrant 1, you would go to 3. And if you were in quadrant 2, you would go to 4. And if you were in quadrant 4, you would go to 2. And if you were in quadrant 3, you go to 1. So it diagonally crosses the origin. All right, but what it does is actually, I guess there should be an S there, reflects across the origin. All right, so that's that. So you can fill in the missing pieces there. Now in this guy, we'll do a couple as well. All right, here the difference is I'm giving you the pre-image and the image different each time, and I'm asking you to figure out the dilation. So, okay, so dilation, and for all these, it's going to be centered at the origin because it's a way harder problem otherwise. All right, so what am I looking at? 5 turned into 15, but it's a dilation. So 5 turns into 15 by multiplying. I don't care that it's plus 10. None of that matters. It's by multiple. So what do I have to multiply 5 by to get to 15? And then hopefully that same number applies to 1 to give you 3. And of course, if you multiply 5 times 3, you get 15. And 1 times 3 gives you 3. So this is dilation centered at the origin of scale factor 3. All right. What about down here? Dilation centered at the origin. 0 turned into 0. That's interesting. But anything times 0 would give me 0. So I guess that's not a surprise. But 4 turned into 2. And you got to be careful. 4 turned into 2. 2 didn't turn into 4. 4 turned into 2. So it got smaller. What do I have to multiply 4 by to give me 2? Wow, I cut it in half. So your scale factor here is a half. All right, and that's how you would figure it out. 2 times what is negative 4? Negative 3 times what is positive 6? So the signs are switching here. Heads up on that. All right, 2 times what is 10? Hopefully negative 4 times that same thing gives you negative 20, and it will, of course, in both of these. All right, I'm going to just leave V, actually. I'm going to do S. So dilation centered at the origin. 2 times what is negative 4? Well, 2 times 2 is positive 4, but I switched sign, so your scale factor looks like it might be a negative 2. Well, I don't know. Is negative 3 times negative 2 positive 6? And of course it is. So you'd be looking at that. All right, I hope this made sense to you. It's a pretty important piece to the dilations. Now, the last part. Finding the center of dilation. So when you're looking at this, it's actually super, super easy. All right, if you're ever asked to find the center of dilation, all you have to do, I hope you can see this, it's a little small, darn it. All right, this says JKL. So this is J, this is J prime, this is K, this is K prime, this is L prime, and this is L. All right, and just to maybe make this pop a little bit more, I didn't realize it was so light. Sorry about that. All right, so here is your triangle that I'll try to draw relatively neatly. All right, if you're ever asked to find your center of dilation, all you do is connect the dots. It's unbelievable, right? You're going to line up your image and your pre-image. All right, you line it up, and you say, all right, if I line up J prime with J, and you draw a nice decent sized line. All right, then you're going to line up another 2 points, pre-image and image. And you're going to be like, oh, hold up, let me get L and L prime lined up here. And I do that, and I got, and just for a little overkill, I could do K and K prime, because really technically you only need 2 if you do it right. But since we're all imperfect, sometimes it's a good idea to have an extra one in there. And you'll see they'll all intersect at that exact same spot. Which if these are my axes, X and Y, this looks like negative 2, comma, negative 1. Oops, that's not a 1. Negative 2, comma, negative 1. All right, and that is your center of dilation. All you did was connect the dots and see what point the intersection of the lines wound up on. Now, sometimes it's outside of the figures. Sometimes, like in this guy, it would be inside. And I'll leave that one for you guys to do as well. All you need is a straight edge and something to write with. All right, so I hope this all helped. I'm going to leave it off on that. Video conference later, 9:30 a.m. Hopefully everyone's there. Hopefully you already saw this. And we'll call it a day. All right, thanks so much. Enjoy the day.